My name is Rob Bathurst. I'm the Managing Director of Healthcare and Life Sciences, as Shirley said, here at BlackBerry Cylance now. And the topic of today is going to be artificial intelligence in healthcare cybersecurity, how it applies, how it's been applied in the past, what's worked, what hasn't worked, what we're doing about cyber defenses today as organizations dealing with healthcare challenges, and how we look at the future when it comes to the application of artificial intelligence and exactly what that means. I am not a big believer in slides, so they are mostly placeholders for the conversation, but hopefully the conversation itself will be enlightening. So without further ado, I will continue. A brief introduction about BlackBerry Cylance and myself. So as most of you heard in the news, the full acquisition of BlackBerry of Cylance has completed. And so we are now one global spanning company specializing in healthcare, life sciences, industrial control systems, oil and gas, so on and so forth. And we are delivering that unified endpoint management cybersecurity strategy. Myself, I oversee our consulting team here at BlackBerry Cylance when it comes to healthcare, cybersecurity challenges, embedded systems, IoT, medical devices, all the things you can think of that incorporate the majority of a healthcare organization that are not necessarily your standard compute systems. Why we put this presentation together today was to try and clarify, provide guidance, help organizations think about things and challenges in the space that aren't necessarily just related to corporate computing security challenges, but spanning the entirety of their asset portfolios. So that's, as I said, everything from medical devices all the way through your corporate compute systems, and how we apply artificial intelligence to protect those as part of your layered defensive strategy. So the past, right? All of us deal with the sins of the past, if you will. Everyone in every organization, whether it be a startup to the largest, most complex, world-spanning organizations, deal with the tech debt and the legacy postures of the people that came before us. And it's not that anybody in the past necessarily had any ill intent when a lot of these cybersecurity systems, if any, were put into place. It was simply that the people that came before didn't have the tools, techniques, capabilities, processes, and training that a lot of the organizations have today or are starting to come up to. And so what you'll typically find in a healthcare organization in the past and ones that are transitioning to a more present and future protected state are the defense in depth strategy as applied as we knew it best previously, which was the hard outer shell transitioning to a segmented network inside to prevent potential transition for attackers between critical networks and non-critical networks. That could be your clinical network, that could be a building control network, that could be a corporate compute network. Any and all of those are the things that get segmented in most organizations if they were being proactive in the past. Unfortunately, what you run into is, while it was good intention to put firewalls at the edge of your organization, maybe some traffic filtering, the subsecting of that internal network, if any, actually caused a lot of business challenges in providing, the goal of providing healthcare as an organization. And so a lot of those well-intended segmentations broke down over time. Either the firewalls were set up in such a way that it caused the organization to have to open more ports than they originally wanted to. Some say in some cases with some people we've known in the healthcare space, the firewalls have been removed entirely because the pain of administration and not having the specialized skills required have caused them to just remove it. And so what you have is that legacy hard outer shell approach with some segmentation and the legacy endpoint management technologies that you usually have in most organizations, your traditional AVs, your SCCMs, kind of your core tech portfolio, is what we find in a lot of organizations currently. What has worked that we've noticed that a lot of organizations have adopted or continue to adopt is parts of that segmentation strategy, pieces of protecting those specialized networks and the thought process about how you segment and architect around that. What we found to be the most effective legacy approach when it comes to applying technology and dealing with the things that are already inside of your environment, it usually comes in a couple different steps. Architecture and evaluation is your primary step when going through and determining whether or not you have the right tools and techniques and capabilities to manage the existing threat, which in most cases you find that there's gaps. The second one is looking at the technology you do have and figuring out how to apply those tools to their best possible use. A lot of organizations, as I said, purchased a lot of equipment in the past, a lot of technology, and the person or persons responsible for updating, delivering, and coordinating that technology are no longer with the organization. The strategy changed. And so a lot of owned technology is sitting dormant in a lot of organizations and not being applied to the fullest. So it's architecture, it's evaluating what's currently in place, and then lastly, figuring out how you can build areas of excellence for the future, right? Building on those lessons of the past that allow you to put technology in place, those AI, those future-leaning technologies, those present-day defenses into your organization so that they don't cause conflict. They're architected around your existing security strategy or your new security strategy, and that they address the sins of the past, if you will. They address the legacy equipment that's there. They address the legacy concerns and that residual risk that you carry. And so what we tend to focus on as an organization when we're looking at deploying AI-based technologies, we look at the totality of an organization. One of the failings of traditional technologies that don't have the ability to rapidly adjust or prevent future threats from taking hold is that they only function for the single systems they were designed. When we look at how we apply AI technologies in healthcare cyber defenses, we're looking at the totality of that environment. It's everything from, as I said before, building management systems to medical devices to clinical support technologies, third-party risk. You have to look at everything, right? You have to look at the whole of your environment and figure out which technologies apply to which scenarios and how that AI is being leveraged to increase your overall defensive posture. So that kind of brings us to the present, right? The present is where we deal with the evolution of AI-based defenses and offenses. One of the things that most organizations either do or don't take into account when they're evaluating technologies is that there are AI-based offense coming, right? There are technologies out there, there are attackers out there, there are threats out there that are using the same techniques that we use to build defensive platforms to build offensive platforms. It's the adage of a sword can be used to both attack and defend. The same techniques that we use to build your defenses can be used to build offenses. And so by investing in AI-based technology, it allows you to stay ahead of the curve when it comes to reactionary issues. The majority of organizations that find themselves compromised are usually put into a position where the technology they have is addressing a legacy architecture, a legacy design, or a legacy technology concept like your traditional AVs, and they're unable to keep up with the threats that are present today. And so we look at how AI can be deployed in an organization, where it can be utilized. And typically the best examples that we can break it down for visualization is in two places. One, your endpoint prevention technologies, such as Cylance Protect, or some of the other ones that you may be using from various vendors that have the capability to prevent malware from taking hold. The other is in a lot of healthcare organizations, there are large deployments of electronic medical records and health record systems, your Epics and Cerners and Allscripts and MedScripts and all the various vendors when it comes to medical records management. That is where the other deployment of AI tends to be, not by Cylance in particular as a vendor, but other vendors are addressing that for appropriate access, for records control, for determining whether or not somebody's behavior is deviating. The reason I recommend looking at the technologies that apply to medical records, even if it's not your primary responsibility, is because the concepts that they use to understand whether or not a clinician or a practitioner should have access to a particular record at any given time would be inordinately complex, using rules and heuristic patterns. And so that's a great example of some companies out there that are going towards AI-based defenses for things like health records, medical records, and so on. And so, it comes down to looking at it and understanding what the AI does using the two examples that I just gave, one on the health record side, one on the endpoint security side, and figuring out fundamentally what question is being asked and what question is being answered. The evolution of AI defenses has given us a lot of marketing material from various organizations in the industry talking about, we have this technology and we have that technology and this thing does that thing. And so as good organizations, ourselves included, when we find techniques that are adopted by the market and very successful in protecting our clients and our customers, we adopt those just as anyone else does. The problem with that is a lot of organizations took the work that Cylance did and they said, well, AI is really working. It really seems to be catching on in things like healthcare. And so we need to make that too. And the problem that leads up to is there is an uncertainty in whether AI is just the new cloud buzzword, the IoT buzzword, or whether or not there's a practical reality to it. And so all of my healthcare clients that I talk to and all of our customers in the healthcare space, whether it be deploying something like Cylance to protect your endpoints or whether it be dealing with technologies to protect medical records or technologies to protect medical devices, ultimately I tell them to tell the vendor, give me the answer to the question. If you can't give me the question you're trying to answer and you can't give me the answer to that question that you're trying to answer, then you don't understand your own technology well enough to successfully deploy it in a way that will protect me as a healthcare organization or any organization in general. The application of AI as it is, especially in current cyber defenses, is not uniform. There are technologies like Cylance that puts the machine learning model, the core detection and prevention technology down on the endpoint. So it processes locally, it works offline, it deals with issues at a individual compute system level. There are technologies that try to apply the same anti-malware approach from the cloud, which if you're constantly connected to the internet, could be a potential solution. There are organizations that use a hybrid model because their model on the endpoint is not as complex or as robust as it needs to be to function in a truly preventative fashion. And so they use a cloud decision support system. So how the AI is applied architecturally is as important as the efficacy of the AI itself. So when we're dealing with organizations that are attempting to deploy different AI-based technologies for defenses, that application of how the AI is delivered and whether it maintains its efficacy in all usage scenarios is a big question that we try and help our customers answer. So, as you evaluate technologies for AI, as you evaluate what you're going to apply in the future, always remember to ask the vendor, what question are you trying to answer and what's the answer you're giving me and how does that matter? to me as an organization. The other thing we find a lot right now, unfortunately, again, as I pointed out, is that AI is everywhere. AI is being crammed into every piece of technology you could possibly think. It is being applied in many different ways. It is going into everything from your anti-malware products to your firewalls, to your net flow analysis, to your architecture tools, to literally everything. And so, as I said, not everything is being applied equally. Not everything is answering the same question, and not everything is maintaining its efficacy in all states. So do your best to evaluate the technology for what it's for, and not just for the sake of it having AI. True AI, as we see it today, true AI in the present, should be able to reduce the need for a person to be in the loop to evaluate whether or not that decision is being made correctly. It shouldn't require an analyst. It should be able to prevent against future threats without updates. It should be able to evaluate and give you a result that matters to you without significant tweaking, learning, or changing. The other area of present-day based AI technologies that a lot of organizations are dealing with also is behavior-based. Their credential use, credential misuse, how you deal with things. That's kind of the next evolution. That's kind of the future is how you maintain whether or not you are who you are over time, which is a far more complex model than your typical anti-malware model. Your typical anti-malware model is based on a simple question, yes or no, whereas your user-based models are much more might be, which is what AI is good at answering. So, moving on to the future, where we see cyber defenses in healthcare going, where we see the technology being deployed. One of the advantages we have as being a cybersecurity vendor, and now with the BlackBerry acquisition, is we have a very large footprint into the other compute devices, the IoT devices, the industrial control systems, the medical devices, the vendors that everybody buys, but nobody really understands what their security posture is. Because for a long time, it was just a black box that was deployed into your organization that performed a function. As long as it was functioning, that was fine. So where we see the future going, where we see the real kind of next leap in AI application is going to be on those other devices, on those widgets, on those medical systems. And the reason for it, I think, is known to a lot of people, that the boundary of healthcare, the boundary of where a person receives treatment is extending beyond the door. It is really going towards telemedicine. It's going to individualize therapeutic systems. It's going to in-home deployments of various technologies to monitor and react to the healthcare of an individual. And so with that comes new challenges. With that comes the inability to apply traditional security technologies inside someone's home. We were dealing with a healthcare organization that was looking at how they can provide continued care while maintaining the security posture that they'd expect on a particular piece of diagnostic equipment that was being delivered into patients' homes. And you work through many scenarios. You work through you can't deploy a firewall to their house, and you're not going to deploy a router so that you can create a trusted connection back into your network. The technology that is being deployed requires Wi-Fi. It's an embedded system. It has software on it that you only partially control, if control at all. And so you work through all these challenges, and you realize there's not a lot that the organization can do and there's not a lot that you can deploy to the device, but that's where things like the application of AI can come in. As an organization, you have the power of the purse until the check is signed, if you will. And so you can demand technologies, you can demand capabilities, you can demand answers to questions that AI would be very good at answering. Because it doesn't require those updates, because it can be deployed in a very specific way. And so what you're dealing with as you look at the answers to this question in this particular scenario was, how do you deploy your security posture into the organization? And working with the vendor, working with the healthcare provider, the delivery organization, we came up with a strategy of deploying different technologies into the vendor's technology that allowed things for preventative AI capabilities, that it allowed for the AI models on their network flow analysis tools to be utilized by back channeling basically the syslog messages through a proxy. Nothing that actually impacted PHI. This particular device didn't transmit, store, or do anything with that. It was simply status messages off the device, which you'll typically find in things like infusion pumps or dialysis or insulin. Those are the typical types of devices you see deployed into people's houses. And so you still have to have security on them. They're still somewhat under your guise as an organization. And so how you deploy that, how you set the security model in the future, how you architect that is very important. And so where we see AI being applied next is that step, is the future, is that device. We're moving the security posture from your corporate compute down to the edge. That's your medical systems, your IoT widgets, your building management, the places that most organizations have a tremendous amount of exposure that they don't actually realize or they don't really grasp fully. Most of your typical healthcare organizations have 5.5 roughly IoT connected widgets per bed, depending on the organization. It could be more, it could be less, but roughly that number. And so the majority of those don't have security built into them. The majority of them don't have defensive capabilities. And so due to the post-market guidance and pre-market guidance that's come out from the FDA, a lot of those device manufacturers, when it comes to FDA certified medical devices, are looking at ways to deploy AI models into them, to deploy future technologies, the ones like Cylance, like Protect, like Optics. And so that's where we see the application of that technology. That's where we see it being integrated, is into that edge compute device. The other big area that I mentioned previously when talking about the present is that concept of that concept of user, understanding the user, right? That is the future. That is the last great attack surface, if you will. Denial of service being one that really has less to do with AI right now and more to just do with a bandwidth game. But for the practical use inside of an organization, we as an organization really see the value in things like understanding whether or not credentials are being used or misused, abused, whether or not people are who they are. Those are where we see the next leap in the application of AI is for that purpose, is for understanding who people are and what they're doing in the context that they're doing it. Is the clinician logging into the EMR? Is the nurse logging into the system? Is it an attacker that has stolen the credentials? Is it somebody actually interacting with their compute system in the proper way? That's kind of the next leap in the application of AI. The other thing we see a lot that's not necessarily being applied by Cylance, but is being applied in the industry in general, is this concept of preventative maintenance. And the preventative maintenance capability in some of these devices, medical technologies, large industrial control systems, also allows for the collection of data and the application of cybersecurity as it relates to understanding when the device is failing because the device is failing, or understanding when the device is failing because of an attack. And so that's another interesting application of AI that is currently being researched and looked at. I'd recommend anybody who wants to look at kind of the future of AI and what's going on and understanding how it's applied to cybersecurity. The Cylance Data Sciences team actually put out a book about the applications of artificial intelligence in cybersecurity. It's a really good read. The other thing I would look at from a healthcare perspective is, HIMSS, the workshops at HIMSS are very good resources. The FDA working groups are also really good resources to really understand where the industry is moving towards the future, how AI is being applied, where it's going, where we see the risk, where we see the threats as it is. So, closing thoughts on AI and just to kind of sum up the bigger points that I was referring to as during the presentation is AI will not take over the world. It will be in almost every part of it as we continue to go into the future, but it will never, given our current compute capacity and understanding, reach the point of general intelligence. General intelligence, the Terminator fear everybody has. It will not reach that anytime soon. And for most cases, AI is meant to be specific. AI is meant to do a particular job. We don't need things to be general classifiers in cybersecurity. We don't need things to be generalist. The problem with being a generalist is human beings have a great capacity for understanding random concepts, but they also fail at understanding specific things. And our great giant brains in our head that are able to understand many things also lead us to make many mistakes because of bias, because of what have you. So as the AI gets more complex, as it moves towards general intelligence, the Terminators of the world, if you will, it loses its ability potentially to do very specialized jobs. And so that goes back to the thing I mentioned before when talking to a vendor who's applying cyber technologies and AI technologies. Ask them the question they're trying to solve. Ask them the answer they're trying to produce. Because if they're truly applying AI in a way that's going to be meaningful to you, they should be able to answer it. They should be able to give you the reasons they're applying AI. And it shouldn't just be for the sake of having a buzzword. It should be using it to prevent future malware outbreaks because the model is designed to do so. It should be understanding data and pattern, attacks taking place on the network because that's what the model is designed to do. It should be, understanding how it's being applied to protect your PHI. If it's a DLP solution, whatever it happens to be, understand how the model is built, why the model's built, what their process for updating the model. Models are not DAT files. Models are not things that they're not big lists of things to look for and understand that they're bad. Models have biases built in by the people who train them. Models have, the machine learning models have their own issues and their own challenges and their own complexities. And so really understanding how it was built and why it was built and what the question's trying to answer is very important. And then, lastly, the other devices, the medical devices, the risks, the threats to those, odds are you're not going to see a directed attack towards a medical device right now. What you're going to see a lot in the present is collateral damage to those medical devices, stuff partially installing, stuff attacking and scanning opportunistically, but not specifically targeting. It doesn't mean it's not coming. It just means currently the vast majority of attacks you see in the healthcare space are coming from, phishing attacks. They're coming from drive-by malware attacks. They're coming from droppers and downloaders, which is why as those become more complex and as they continue to spread out, the application of AI for your cyber defenses is going to be more important because you're not going to get enough resources and enough money and enough time to to deal with those. And knowing that the vast majority of threats towards your clinical support systems are going to originate inside of your corporate compute environment is why it's important to understand how to apply AI technologies there first, then your clinical ecosystem, the things that support the medical devices second, and then lastly, defending the medical device themselves, which is a shared responsibility between the vendor and the health delivery organization. So it's a evolutionary step right now for a lot of organizations to apply AI into their cyber defensive technologies. It's a large leap from an architecture, design, and strategy perspective for health delivery organizations to utilize those new technologies coming out. And it's a shared responsibility between the security vendors, your IoT and medical device vendors, and the delivery organization itself to maintain the security posture and constantly improve it to ensure no negative impacts to patients. So with that, I thank you for taking the 30-ish minutes to listen to me talk about AI, how it's applied, how we view it, what issues there are with it, and if anyone has any questions, I'll be happy to answer them in the time we have remaining. Any particular reasons? Cylance is actually outside the U.S. market. Yeah, we have a very large presence in Europe with a lot of organizations. We have organizations in the Asian Pacific region. So we are a global company, and we do sell to many, many countries. If you have a country specific, I'm sure our sales team or our marketing team could let you know if there's anything there. But yes, we are outside the U.S. market, and you're welcome on the infusion pump.
Thank you, Rob, and thank you, participants, for your questions today. We look forward to seeing you in the future, either at RSA at booth 6145 in the North Hall, or join us for our weekly webinars. Thank you. Thanks, Rob.
You're welcome.